Good morning, Charles and Brooke and everyone else. So thank you for joining the Cannabis Data Science Meetup group. My name is Keegan, the founder of Cannalytics, a company to make cannabis analysis simple and easy. Today, we'll be looking at lab results in Washington State, and Charles has prepared some work trying to predict if a sample may fail quality assurance testing. And then I can follow up with some analysis on cannabinoids afterwards. So without further ado, Charles, would you like to present some of your work?
Sure. Let's see. I've actually never presented. Where is that? And can I even do it?
So it should look like a box with an up arrow.
Oh, that one. Okay.
Cool.
Okay. So previously I had done some work with trying to predict sample failures in the lab, and so I came up, and so most of the stuff at the beginning is just sort of reading in the files and cleaning them up, and then encoding them and splitting the data into test training and testing sets, and then because there's a huge class imbalance. There's way more passing samples than there are failing samples. It calculate these class weights to help the model compensate for the lack of failing data. And then this just all the data is categorical, right? It's it's not numeric. So in order to use Cat Boost, you tell it to which columns are categorical, and then Cat Boost is really good for dealing with categorical data, and it tends to be a fairly good classifier. So you train the model, and what I had done is I had taken this data and used Optuna to come up with an optimal set of parameters for this particular data with Cat Boost. And Optuna is a genetic algorithm that goes through and it'll try something, and it'll try a set of parameters, and then it'll actually come up with a population of parameters, and then try those, take the best ones, and then use those to come up with new parameters. And this takes about a day and a half to run. Last time, a big part of the problem was I didn't really have a goal. So Keegan had pointed out that the big goal was to not miss any failing samples. Because last time I was kind of trying to optimize everything. So I came up with this particular model, and it only misses one of the failing samples.
Nice.
So, right, it pretty much meets your goal. But also Cat Boost will tell you like how important each one of the features were. So the lab ID turned out to be the most important for some reason. I mean, maybe either a certain lab or certain labs are more strict, or certain labs just tend to get more samples that fail. We don't really know. But the whole thing bothered me. This is just kind of really odd. I mean, there's obviously a lot of false positives.
Yes.
88,000. So that's a lot. So I was wondering, is this thing really learning anything? And the answer is no. It's basically a dummy classifier. So what it does is it predicts that marijuana fails 99% of the time, when in reality it only fails 12% of the time.
Yes.
Um,
And that was the sneaking suspicion I started to get last time, was maybe there's a certain product that tends to fail more than others. And like you said, it's basically just pinpointed that sample type and just, and you're basically saying it's just saying that that sample type fails every time. The-
yeah, basically, yeah,
and
99.5% of the time. So yeah, it basically, well, that's what, or the classifier thinks or predicts that marijuana fails almost all the time. So, and but yeah, it does fail more than the other product types, but it only, in reality it's only 12%.
and is this mixed marijuana by chance? Or
It's just labeled as, the type is labeled as marijuana. I don't know what.
the intermediate type by chance?
No, that's the actual product type.
Okay, we'll dive into some of this data here in a second. So from my understanding, the intermediate type is really is kind of the main classifier. So like, so for example, here just like the type, right? So everything's going to be categorized essentially as an end product. Well, everything that makes it to the store shelves. And so I'm curious about the product type being
So
used.
for marijuana, the main product type, or was it subtype, or what did you say it was? I can't.
It should
Intermediate
it should
type.
be intermediate type.
It was intermediate type, and so that was flower. But if you go back to the old notebook, there's very few entries in the table that had intermediate type. Most of them were missing. Product type, or just type, was the one that was filled in the most. So intermediate type was missing most of the time. Like 85% of the entries were missing intermediate type. And I did try and go through and fill those in, but it just kind of didn't seem to, there was kind of no clear way forward with that.
Okay, I'm just looking at some of the variables here. So were those just not end products by chance? The ones without intermediate type?
No, in product also was missing a large number of intermediate types. I would have loved to have used intermediate type as an input, but there was kind of no clear way forward as to how to fill in those missing values.
Okay, so let's power on for now, and then we'll start poking at this data here in just a second, because I've done some follow-up work with cannabinoid analysis, and then we can dive back into this sample type discussion. But please continue, because no need to get hung up on this for the time being.
Okay. Yeah, no, I'd be interested to find what features are really viable, and how we could fill in some of that missing data. So the next thing was in product, which was predicted to fail 1.5% of the time. And it actually fails. In reality, it fails 1% of the time. So this was pretty close.
And can I pause you there? So this is where savvy cannabis licenses will do some interesting, analytics. predictive behavior, cost benefit analysis, because essentially what you can do is you can factor, say, a 1% chance that your products fail into your cost, your estimated costs. So that way you can budget correctly. So for example, if you don't take that 1% chance of failure into consideration, so that's in economics terms, that's a cost, right? Because there's a 1% chance, and upon that chance, there's a cost, right? You're gonna have to expend to destroy the product. It's going to be a loss in inventory. So that's essentially an expected cost. So long story short, I think this is something that businesses should take into consideration. So when you're starting your cultivation, I think you should factor into your cost the estimated probability that you may fail. Because what I've seen is cultivators, processors, they don't account for the probability of failure. And so then when something does fail, it becomes a disaster, because they say, oh, like they didn't budget that, they didn't plan for that, and now all of a sudden it's hard for them to make ends meet. So I just wanted to pause you there just to kind of drill that point home, that although it's just a 1% chance of failure, if you're producing large amounts of flour or concentrates, 1% is, not, it's non-negligible. So it's something to pay attention to. Anyways, Charles, just wanted to drive that point home real quick.
Okay, no, that's a good point. That's especially in startup businesses. Yeah, there's nobody. Yeah, nobody. A lot of people don't factor in that something could go wrong, and when something does go wrong, then it is a disaster, because they're operating on such a tight budget, and they haven't thought about these things. So, yeah.
And you raise an interesting dimension, another factor, the size of the company. So this number may be biased down. So say large cultivations, they have things under control. Well, maybe for the most part, that's an assumption. But maybe they have their flower rooms well quarantined, and they're able to expend a bit more to keep their failure rate low. Plus, they're sending in tons of samples, so it may look like the failure rate's low, but if you do it conditional on business size, I wouldn't be surprised if smaller businesses may even have a slightly higher failure rate.
That's interesting. And so, is there a way to get the size of the cultivator out of the data, or maybe even the length of time they've been in business?
Well, there's a couple ways you could proxy the size of the business. So you could just do sales. So there's sales data. So you can rank the companies by their sales. There is tiers. So technically there's tier 1, tier 2, and tier 3. That data may be there. I suspect it is, but I think that data is there. So we'll want to make certain. So you could just look at the tiers. That would be the simplest. Do tier 1s have a higher failure rate than tier 3? And then next, I would run a regression of, if you can do that, I'm thinking, if you just code it 0, 1 as fail, you may be able to run a regression on like a logistic regression on failure rate on sales. So do companies that have higher sales, is their failure rate lower? And my hypothesis is it may be, because they, if they have higher revenue, then they may be able to expend a bit more just on, quality control, keeping the rooms clean,
Okay.
checking your HVAC system. You know how it is. Sometimes smaller businesses may try to cut corners, try to keep costs low, and then that may or may not result in a higher failure rate. But it'd be interesting to see.
Okay. Well, that's good. That's something I can try out and try and move forward with. So one thing I did want to point out was that in product made up 68% of the training data, whereas marijuana only made up 12%. So the classifier is seeing in product more, so it's able to learn more about it, learn it, learn about it better. So I believe that also was a factor in how on the numbers that came out, because when you go down to harvest material, it predicted that it was the failure was 58% when actually it was 7%, and that made up 13% of the data. So again, it didn't see as much of it.
And are these like microbial failures, or I guess we didn't really break that down, but I guess if it's harvest material, that must be microbes, or it seems a little high.
I don't know, because I only took data that you knew before the testing. Because if you started taking data that you knew about after the test happened, then you're peeking into the future. So, you don't really know a lot, right? You know the type, the producer, the lab. And you could find some things out about the producer, but
I'm not saying as a predicting factor, but I'm saying like as far as how you coded up failures, was there like a variable that's used to mark overall failure status, or are you going through each compound and comparing it to its limit?
well, in the lab data frame, the lab results data frame, there's actually a pass fail column.
Interesting. So this may get complicated, but it could be interesting to start breaking the failure down by what's failing. So for example, concentrates are the only type of sample being tested for residual solvents. So it could be interesting to say, look at what's the chance of a concentrate failing residual solvents. And then you could even break that down of what's the probability of it failing for each of the different solvents. So what's the probability that it fails for butane? What's the probability that it fails for propane? And so on and so forth. And then with flour, you may want to break it down by essentially the microbes. I don't remember them off the top of my head, but we've got the data set here. Yeah, so they're testing for E. coli and Salmonella. So you could look at the failure rate for each of those. And so the way you would do this is you would essentially have to calculate those failure rates manually by looking at for example, the microbial pathogenic E. coli variable, and then compare that to the state mandated limit, which may be 10,000 CFUs. So that's a colony forming unit per gram. Don't quote me on that. So check the whack. But long story short, we could potentially get more granular on the failure rates. So look at sample type for different things.
Okay. Right. Yeah, that's something I can work on. I've been.
So there's so many variables there that you have to kind of narrow it down. So for example, what's the probability of a residual? So what I think would be interesting is, okay, just look at concentrates. So you may have to look at the different types of concentrates, and then try to estimate the probability that they fail for mycotoxins, just broadly for any mycotoxin. I think that's ochratoxin and aflatoxin. So you could just say, okay, what's the probability that a residual solvent fails for a mycotoxin? And then what's the probability that it fails for a residual solvent? Just any of them. So whether that's butane or propane. So that's a bit more complicated of analysis, but once again, it's just going to provide more information to processors. So that way they can know, okay, what's your bigger risk? Are mycotoxins your bigger risk? And then that would essentially come from, biologically dirty. So just kind of dirty input. So that would be like, okay, check your input if your mycotoxin risk is high. And then if your residual solvent risk is high, then that means you want to address your process. So you want to address how you are getting rid of your solvent. How are you purging your solvent from your products, essentially? So sorry to go down that rabbit hole, but there's endless analyses there, right? Because you can break that down a lot.
Right. Okay. Well, that's something to get into, and I definitely have a lot of functions now to deal with this table and cleaning it up and pulling stuff out of it. So
Good.
yeah.
Well, you want to bring us home here, Charles, and then we can potentially get our hands on the data real quick, and I'll show you. You've done a lot more complex analysis than I have, but I've just put together a couple histograms of some of the cannabinoids, and we can just look at the variables and talk about the data. That's what we're here for. But anyways, would you bring us home here with what your main takeaways here and the rest of your analysis?
Okay. Yeah. So, intermediate product failed like 31% of the time, but actually in reality, it only fails like 2%. But it only makes up 7% of the data. So I think the reason that the end product, you get the best predictions from it is that it makes up the majority of the data. So the classifier has enough data to learn something about it, and it doesn't have enough data about the other products to learn anything, or to learn enough to make accurate predictions. I did spend most of the week working on trying to come up with a balanced data set. And I tried several different things with oversampling and even breaking the data up into passing and failing, and then oversampling that. But what I'm finding, I'm kind of finding this, and I also found the same kind of thing with the hemp data, was that I'm not sure that there's anything there to predict, right? These could just be sort of random occurrences, or Yeah, I mean, I don't know that there's actually enough. There's anything that's really predictable happening. Um, I can kind of keep going down this path a little bit further, but
Yes,
I'm not. Oh, go ahead.
I think, well, two things. So you definitely could be right. So we may have to think about another dimension of the data that we could get some good insights from. The second is my recommendation would be maybe even put prediction aside, just look at some conditional averages for the time being. But I would drill down a little further. So essentially what I would do is I would only look at end products. I would pick a sample type. So, well, like a cluster of sample types. So I would say concentrates, and I've got the list pulled up here. So concentrates would basically be hydrocarbon concentrates, concentrates for inhalation, non-solvent-based concentrates. I would leave the mixes out. And then you've got CO2 concentrate, ethanol concentrates. And then you may or may not want to include the food grade solvent concentrates and the non-solvent based concentrates, right? Because you would, so the non-solvent based concentrates, so those are going to be like what they call bubble hash, which you would use essentially water as your solvent. So you wouldn't expect there to be butane in those concentrates. So long story short, you may want to pick a cluster of concentrates, and then I would look, or just do one, like just look at hydrocarbon concentrates. So just look at end product hydrocarbon concentrates. What's the probability of failing for residual solvents? And then potentially for the different residual solvents. And I think once you get that granular, I think that could actually provide useful insight as simply a conditional average to a process. So then you would just tell processors, hey, historically, hydrocarbon concentrates have an X% chance of failing for residual solvents.
Okay.
Similarly, you could do it with flour, and there your principal variable would be your microbes. So what's the chance if you grow flour, what's the probability your end product, your end flour, what's the probability that that flour will fail for microbial contaminants? And it may be hard to predict, right? Because those may be like 1% or less. But I think just knowing what those percentages are could be useful for people planning their cost structure, essentially.
Right. Okay. And I guess the other thing to take away from this is, on the surface, this classifier looked really good, but after we dug into it, it really wasn't much better than a dummy classifier. So you shouldn't
Well,
trust these things outright.
and that's how you could potentially do some robustness checks. So just throw in a dummy classifier. And so I think it's fruitful, interesting analysis, right? Because it's better to do it than to not do it, right? So I think we've learned a lot. So if you're okay, Charles, I'll go ahead and start presenting, and that way we can see some of these variables that we've been talking about.
Okay.
So just to show you what I've been looking at over here. So these are essentially the intermediate types that I've identified. But just to kind of give you a bit of a background before we just dive straight into that. So essentially, right, we're working with this Washington State data. We're primarily looking at the cannabinoids. Well, the lab results in general, not necessarily the cannabinoids. And so I essentially wanted to do a quick analysis here. And so there's been a lot of talk about delta 8 THC. So I just wanted to take a quick look at delta 8 THC. And then I was just perusing the literature to see if what's the latest research being done. Found an article here. Let's see, when was this published? It was published not too long ago. Oh yeah, so it was just published July 10th. And so essentially what they did was they just looked at edibles in Jamaica. And so these, not necessarily from stores. So some of these were confiscated from high school students. So these were just, I think they only had around 50 or so. So they basically had around 50 edibles that they came by, and they were looking at the THC and CBD found in the edibles. And so they're looking at the THC CBD ratio. And so I thought, well, you know, they only have 50 edibles. We probably have a lot more edibles in the lab results data set. So why don't we try to essentially replicate their analysis and see what we find with edibles here in Washington State. So that's just a bit of background about where I'm coming from, just to build on Charles's analysis. Okay. So let's see if we can't get a terminal opened here. So it'll give me about 30 seconds to read in the data. So we're working with these lab results from Washington State. So we've got about 2 gigabytes of lab results here. And just for a refresher, this is the same data set that we've been working with for some time now. And then I'll be working to get an updated copy of this data set to the most recent time period, so that way we can refresh our analysis. Okay, looks like we've read in the data here. So first things first, just want to look at the data. So we have almost 2 million observations. To go ahead and show you about the sample types here. So first off, just to show you the data points we're working with. There's a lot of analytes, so pesticides, solvents, microbes, terpenes. Well, there's not actual terpene data. Cannabinoids. Okay, so the main identifiers are essentially type and intermediate type. And to show you the guidebook, links up here. Okay, so returning to our type discussion. So essentially, there's several broad types. So The end products are what end up on the shelves. The intermediate products could potentially be processed into other end products or become end products themselves. So what I find most useful for determining what the sample is essentially its intermediate type. And so this is technically the subcategory of the inventory type. And so it's conditional on the type. So this is where we start to lose a little bit of the rhyme and reason. So for example, the concentrates are always your intermediate types, or always your intermediate products. Your edibles are always end products, it looks like. Hold on. So it's a little bit of a mess, but essentially, if you just look at just the intermediate types, I think it gives you a decent understanding of what the product actually is. So for example, if you just look at the intermediate types for hydrocarbon concentrates, you'll just get hydrocarbons. Flour, it's a little bit tricky. I was looking at the data this morning, and it doesn't appear at first glance like there's a big distinction between flour and flowered lots. I've got a sneaking suspicion that that flour is intended for processing and flowered lots is intended directly for sale. In my analysis here, I just combined flour and flower lots and just called that flower data. And so for now, I'll just be looking at flower data.
So flower lots is an intermediate type for end product, and flower is an intermediate type for marijuana. If you look at my version 1 of that notebook, it breaks that down and breaks it down by percentage. And actually,
Exactly.
flower is the only subtype for marijuana. There's a bunch of others listed, but flower is like at 100%.
Exactly. And so it may even be worth asking the LCB themselves, but essentially, I've got a sneaking suspicion one is designated for stores, and the other could potentially end up at stores or could potentially end up at a processor. It looks a lot like they treat the two types the same. So once again, just sort of deferring to what it brought up in the last meetup, where this is not a bulletproof analysis here. So if you're doing, research on your own or commissioned research, you're going to want to do a lot more research and dive in and answer these questions. So, for example, it wouldn't hurt to just email the Washington State LCB and ask, okay, what exactly is the difference between flower and flowered lots? They may or may not have an answer, but for now, we'll just do an expedient analysis, but it's worth reading up a bit more because, like I said, I'm not 100% certain, and I need to become certain. Long story short, if you have any insights, definitely let everybody know. But just to keep powering on here, I'll just be looking at flower and flower lots. We'll worry about the distinction later. And out of the samples, out of, the almost 2 million, there was about 239,000 flower lots. So I think, Charles, this may have been what you were hitting at, where there's a lot of data there that may not necessarily have lab results. Is that the case? Is that what you're finding? Or
There's lab results, but like the intermediate type isn't filled in.
yes. And so that's it. That's interesting. So we need to find more. So I wonder if those are observations that we're just missing an intermediate type, or if those are other types of samples. So I think there's more discovery to be had here. But just to keep powering through, not to get bogged down. And so essentially I'll run through this analysis, prefacing it with the fact that we still need to find out a bit more about the variables. So this analysis should be repeated once we learn a bit more about the data. But just to demonstrate some of the techniques we could use. So first research question, I was just curious about delta 8 THC because this was actually at a discussion the other day at the Washington State Liquor and Cannabis Board deliberative dialogue. They were talking about delta 8 and synthetic cannabinoids. So I was curious, okay, so what does the presence of delta 8 THC look like in an ordinary flower? So out of the almost 240,000 flower samples, a little less than 2,000 had delta 8 THC. If you look at the actual percentage, that's less than 1%. So about 0.75% of all the flower samples tested had delta 8 THC. So it appears to be a rare compound. And essentially, I've restricted the sample to exclude outliers because, so for example, let's just take a quick description. So you'll notice, okay, the mean is around 1%. However, we've got an observation in there that's coded at 64% delta 8 THC. And I don't think that's the case. So it's a flowers sample. So I think there may be either miscodings or some sort of outliers in the data. So I gave it a generous 5% exclusion of outliers. So I'm restricting it to the bottom 95 percentile. And just to look at that data, here would be your distribution or your density of delta 8 THC in flower. So, and then this is actually of the flower that contains delta 8 THC. So this chart would have a lot more zeros if we included all the flower that didn't have delta 8 THC. So I think it's interesting to observe. So it just is this rare compound, and there could be more work to be done there to, for example, what are some of this could be a huge data dump, but what are some of the strains? Oh, I thought there was a strain name variable, but anyways, what are some of the strains that are more common. Maybe it's product.
Now to get the strain, you have to merge it with the batch,
Ah,
and then merge that with the strain.
that's right. So you have to do a bit of legwork to attach those data points, but I think that could be fruitful legwork. So, for example, what are the sample types that have delta 8 THC? Because as we saw, there's only about 1,800 of them, and there could be duplicates, right? So there could be one strain that's grown many, many times. So I'm curious, okay, so what are these strains that are growing, that are producing delta 8 THC? And
There's also a surprisingly large number of entries that are missing the strain ID.
exactly, so this could be where it's just essentially not the best data entry. So different licensees may not be consistent about how they're entering in strains and type, although the system, I'm sure, would like things to be nice and consistent. So that's that's the reality of working with with real data. Is it can be a mess, right? I heard. Yeah, so we need to be careful with the data points, because I was hearing somebody say, oh, there's an acronym GIGO, where it's garbage in, garbage out. So you have to be real careful about what data points we're looking at here. And so that's why you may have to. So for in this case, I'm excluding the outliers, because I just personally don't believe that there's a sample that actually has 64% delta 8 THC. So that's the reality of the situation. but but just to keep moving on, unless you've got some more observations, Charles or Brooke. So just to
I was gonna say I don't have any questions.
okay. So that was just a little look I wanted to do at delta 8 THC, just because there's been a bit of noise about that. Next, just to keep doing some cannabinoid analysis, I thought, okay, we could reproduce this histogram. This is simply a histogram of the THC CBD ratio of the solid edibles in Jamaica, a sample of solid edibles in Jamaica. So we can do that in Washington State. So going back to the sample types, you'll see that there are a handful of edible classifications. There's topicals, there's capsules, there's solid edibles, there's tinctures, there's cooking mediums, there's liquid edibles. There's transdermal patches. So there's a handful of non-traditional cannabis products. Just for the sake of simplicity, I am just doing analysis here on solid edibles, because I believe if you look at the breakdown of the edibles that they are looking at in Jamaica, you'll see they've got baked goods and candies. They do have some beverages, so we may want to include liquid edibles. However, for the most part, it looks like baked goods, chocolates.
So in our data, solid edible is 37% of the intermediate types for end product, and liquid edible is only 10%.
So honestly, let's do this analysis. We've got time, so let's do this analysis real quick with solid edibles, liquid edibles, and then solid and liquid edibles. So just to do it real quick, just with solid edibles. So I saw that there were about 9,000 solid edible observations. And so this is what's so cool about our analysis here in the Cannabis Data Science Meetup group is this paper, right? So, right, these authors have their article published in the Journal of Cannabis Research, and it is incredibly interesting because we'd want to know about the cannabis in Jamaica. However, got to keep in mind that, right, no, they don't even have 50s. They've got 45 edibles collected over a 4-year period. And so, I mean, for starters, you could argue that this data is already dated. I mean, it's 2021. So is it even relevant to compare edibles in 2021 to edibles in 2015? Maybe, maybe not. And so I think that's what's cool about our analysis here is, a lot of the times your access to data is limited, right? So they're just looking at 45 samples and, that's fruitful, right? Because you still get a breakdown of the THC CBD ratio. We can collect data in Washington State. It's public, it's free. Anybody can collect it. We've collected it. And we have 9,000 solid edible samples and so we can even find our date range here. So oops, I should have just done this on. Wonder if I can. Well, luckily I have this over here too. Okay. So